Okay, I've got a question about British and Irish lines 2005. I'm interested in nationalities and playing positions, and all the data is in the table. So now I've got to answer some probability questions. So I want the probability that the player was a Welsh back. Okay, so I'm going to be interested in the number of Welsh backs, so that number there is going to be of interest, but I also need to know what I'm dealing with in terms of my total. So I'm just taking starting with the player selected at random from the squad. Okay, so I need to know the total number in the squad, and with these two-way tables we always need to, you can do this on the exam paper or you can make your own table, but if we work out the total for each row and the total for each column, where am I going to find the total number in the squad? Well, at this point there's no restriction on which player could be chosen, so I want the overall number. Okay, so in terms of the answer template for that, all you need to write is a fraction. So the number of Welsh backs on the top, total number in the squad on the bottom, and that's all you need to do. No other method is needed in this case. If it cancels down, you can do, but they will give the original fraction full marks. Okay, so for all of the remaining ones, we're going to set up fractions in the similar way. It's just a question of getting the correct numbers on the top and the bottom. So the next one, still dealing with the whole squad, so that helps with the bottom number. This time the player has to be English. So English is the whole of this column, so it's not just them, it's the total number that are English. The next one is not English. Okay, now you can do this two ways. You can either tot up all the players who aren't English and put that over the total number, or you can use your previous answer, because we know that to get the probability of an event not happening, we can just take the probability that it does happen away from 1. So that's why this is just worth 1 mark and that one was worth 2. But you can do it by totaling these numbers if you want. Now it gets a little bit more interesting. Here we've got this keyword given. So what are we given? We are given that the player was a back. So this is the clue to what our total is going to be out of. Okay, so we are interested in all the players that were backs. So we're basically just interested in that line. So for the first time, we can forget this overall total. We can just look at the information on this row, including the total number of backs. And I need to be interested in the fact that they were Irish, given they were a back. So I'm interested not in these Irish forwards at all, but I'm interested in this number here. So that's how we get the top number and the bottom number for that one. And then the next one is also got this magic word given in. This time we're given that the player was not Scottish. So whereabouts in the table am I if I know the player was not Scottish? Well, here's the Scottish data, so that means I'm basically interested in getting rid of this data here about the Scottish players, and then the total I need is going to be all the remaining players, and I am interested in the probability they are forward, ignoring this column again, so I need to combine the numbers of forwards. So top number is the combination of the non-Scottish forwards, but the bottom number is the total number of all the players in the table who are not Scottish. And in the template, all of these answers are just in the form of fractions, where you have to supply the top number and the bottom number each time, as we've discussed. Okay, now in part B, we've got 4 players were selected at random from the squad, and we want the probability that all 4 of them were English. And because we can't use any player twice, this is sampling without replacement. So the probability that the first player is English we've already done. Okay, it's the number of total number of English players divided by the overall total. But if we assume that that's happened, then the probability the next player will be English, there'll be 1 less English player and 1 less in the total. So this is where you have to take into account for each new probability in your multiplication, you have to adjust both numbers. We're multiplying because we need the first player to be English and the second player to be English and the third player to be English, and so on. So your answer for this is going to look like 4 probabilities multiplied together, first player being English, next one being English, so adjust the numbers again, multiply these all together on your calculator. The answer may come out as a fraction or as a decimal. If it's a decimal, give it to at least 3 significant figures, but any correct form should be acceptable.